joining our webinar. Today, we're very happy to have Manav joining us. He's the co-founder and lead data scientist from Blue Onion. We're going to go through what is the most well-known topic right now, prepare for the future, how AI, machine learning, and even ChatGPT impact accounting. So welcome, Manav. How are you today?
I'm well. How are you?
Good. So we're going to go through some topics and we're going to do it more like a Q&A style. We are very curious about your background. So can you kind of give a quick 5-minute run through of what you have done before Blue Onion and how you started Blue Onion?
You know, my background is actually originally in physics and math, and I kind of fell into the AI and machine learning world maybe 10 years or so ago at this point, and have been building data science teams at startups pretty much ever since, different verticals. And you know, the reason that we kind of started Blue Onion, or how we kind of got to this problem, is, you know, everywhere both me and my co-founder Lindsay and Charlie went, you know, we ran into the kind of the same problem we're solving here now, which is, you know, at the end of a period, you know, different teams, the finance and accounting team would come to the data team and say like, hey, we have a bunch of money that we think landed in our bank account. We're not exactly sure where it came from. Can you help us kind of upstream figure out where this stuff came from? And so we spent a ton of time kind of organizing information and helping them kind of piece together what actually happened. And, you know, after thinking about it, we're like, well, there's got to be a better way to handle this. We got to be able to build some kind of a data layer in between kind of the upstream sources and kind of end users to automate or abstract kind of the teams away from having to deal with this mess. And so, you know, it's a combination of a lot of data engineering and machine learning and data science techniques to kind of automate a lot of this stuff away. And that's kind of been our story and how we've gotten here so far.
The first question we have to ask is, what is artificial intelligence? What is machine learning? What a difference between them?
You know, if you grew up around the same time, I guess I did, you know, your perception of AI is generally things like the Terminator, right? Robots that are trying to do something, you know, evil or, you know, disastrous. But really AI is just broadly machines learning to interpret information and do something with them. But, you know, intelligence is such a fuzzy word that practically it's really more appropriate to call what you see out in the world machine learning, which is more of a subfield of AI, you know, where we use algorithms trained on data to perform a particular set of tasks. And, you know, AI has been a field of research since pretty much the beginning of computing, but has gone through a ton of different hype cycles. And winters. So, you know, there's a hype cycle where people think it's going to revolutionize everything, followed by broad disappointment and disinterest. And then that leads to, you know, funding cuts and like lack of interest in research. Some kind of breakthrough happens and the cycle starts again. But in each cycle, there is meaningful progress. It's just kind of, there's always overblown for what's going to happen. And then kind of people have to readjust their expectations. Though I would argue, I guess, the troughs of those cycles have gotten less deep over time as like real progress has been made. And we've been building real products based on kind of some of the AI models and machine learning techniques.
So I chat a little bit more about ChatGPT and why is it bringing AI back to the public view again?
Sure. So just a little bit more background, I guess, on what GPT is. So GPT stands for Generative Pre-trained Transformer. And, you know, generative meaning it actually is creating something, pre-trained meaning it's not taking in new data in real time. It's based on a pre-trained neural network, which we can kind of discuss the details of. And then transformer is a particular type of architecture, which we can also talk about shortly. I won't belabor the details too much, but it's probably the advancement that you know, has led to this current hype cycle, you know, in the last whatever year or so. And, you know, just more broadly, you know, every machine learning model is an optimization problem. So you have an objective function, you define something that you say, this is what I care about. I want to maximize this good thing or minimize this bad thing. And you optimize that function by solving what is usually some set of differential equations, some constrained differential equations. And that's really the heart of all of machine learning. Now, which set of differential equations you solve is a function of like the model architecture. So neural networks are a particular kind of architecture that consists of nodes called neurons, and they're kind of loosely designed to mimic how the brain functions in the sense that, you know, each one can be on or off like a neuron fires in the brain. It's not really like how the brain works because we don't really know how the brain works, but generally you have these nodes that are on and off and they're kind of organized in these different layers. So models today have something like 10 to the 14 of these neurons. They're split into sections. These sections are called layers and they're arranged in different ways. And then, you know, each layer is effectively you apply a transformation via some matrix multiplication and then some kind of like nonlinear function. And I know we can go into the details of that if you'd like, but basically it's a structure of neurons where we try and figure out what weights to apply to these neurons to say, should this be on or off? And in the last decade, this has been the basis of a lot of the growth in AI applications. And you've seen them, in consumer products. So on the consumer facing side, you've probably seen something like the auto tagging of photos if you use something like Google Photos, or so tagging your mom in each photo and identifying that it's the same person is a convolutional neural net underneath the hood there, trying to do the image recognition of kind of what's in these photos. Same with email, right? The auto reply and auto completion features are, machine learning algorithms underneath the hood. Recommendation engines like Netflix and Spotify, like they tend to use different types of models, not necessarily neural nets, but their recommendation algorithms is a subfield of kind of machine learning as well. So I think the recent hype, these types of neural nets have been around for a while. What's kind of the new thing, the transformer piece is a particular architecture that, I think came out in 2016 in a paper out of Google, but really had kind of innovations where, you had these different modalities, convolutional neural nets for images, recurrent neural nets for kind of speech and text. And the transformer architecture, kind of the innovation there, really is you can kind of unify all those into kind of one. There's a convergence into this single architecture of transformers, and there's probably three major components that made it really special. One is this concept of attention and self-attention in particular, and then something called positional encoding. And these really allowed for a much broader, more robust architecture than kind of the very specific neural net architectures that were for each modality kind of earlier. And we can talk about, I guess, what changes. I think, obviously I haven't seen ChatGPT. That's been I guess the most exciting piece, and people can interact with it because it's a language model, right? Like it's easy to talk to it because it, you can speak to it in human text. But to talk about, I guess, how it will change industries in general, it's tough to say, right? Everything's in the hype cycle right now, right? It's going to revolutionize everything. And the reality is it's going to change a lot of things probably, but it's not going to change everything. And we're very much in the early stages. So it's my own kind of personal opinion. I think it's going to have a huge impact on things where the cost of being wrong is generally pretty low. So like, if the reason being is these models are not, obviously perfect. And you've probably seen things called hallucinations that these models tend to perform as well. So usually it's going to be applicable where human language is a big part of what you actually want to do, and two, where if you're wrong, it's not a dire kind of consequence. So something like sales and marketing will probably be impacted a lot more than like medicine per se.
Can you chat a little bit more about ChatGPT and why is it different than any of the other transformers that we have seen?
Well, I would just say the transformer models generally, like Bard, ChatGPT, and some of the others, they're very similar in architecture. Maybe what difference is some of the tweaks in what data they're trained on in particular, and I don't know, maybe some small differences in how the neural net is set up. But generally, kind of the concepts of attention, self-attention, and kind of positional encoding are common across all of them. And I think one of the problems that they all have, or I'm sure you've seen things called hallucinations. So we can talk a little bit about what they are.
Yeah.
So usually when we say a model's hallucinating, it's a plausible but nonsensical answer. So it sounds like something that would be a reasonable thing for the model to spit back, but underneath the hood, it doesn't really make sense at all. So just to talk about why, like, for these types of models, I think it's a good heuristic to think that it's not exactly answering a question, but trying to create something it thinks an answer might look like, if that makes sense, which is why prompt engineering here tends to matter so much. So it's not necessarily about what the question is, but what the question sounds like. Because these models are trained to predict kind of what the next word is in the text that they observe. They want to create a sentence where the syntax and the topic are correct, and they can be really good at mimicking how we sound, but there's nothing in that process that binds them to whether the sentences are correct or accurate. They don't get a penalty right now for producing false information. And so that's where like the hallucinations come in. They want to sound smart, but they don't actually necessarily need to know what the correct answer is. And this will change. I think this is a rapidly evolving space, and this will get better with, people have talked about adding reinforcement learning techniques in here where there's a human in the loop giving kind of feedback to the model. But there is kind of a fundamental flaw that like leads to these hallucinations. They don't really have a sense of kind of the underlying reality that the language describes. So like the hierarchical information for how our brain works and the abstractions that we create, we operate on a knowledge that's like not written down, right? But these models are just trained on kind of the text and information that we see on the internet. So all that background knowledge is kind of lost. So I wouldn't expect them to have the same kind of hierarchical abstractions that our brains create.
So right now, even with Facebook, with all those social media, you want to make sure that you're producing information that's not false, aka fake news. So do you think that ChatGPT will be able to detect what is fake news and what is not?
Yeah, it's a great question. So, there's two things that people worry about, I guess, right now. One is kind of just artificial general intelligence. Is this kind of the doom scenario of this is just going to be smarter than us? I think we're pretty far away from that. These are, like I just mentioned, these are not thinking like we're thinking. And I don't think we're anywhere close to kind of AGI at the moment, maybe 50 years away or something like that. Who knows? It's really hard to say. We don't really know how, the brain works. But the fake news problem, or just fake information problem, is probably a much more plausible one to worry about, or relevant one to worry about, I should say, right now. And we'll tend to find there's going to be a flood of kind of what seems like real information, whether it's from images being created or videos or anything like that. And I think the best way is you're going to have models to like detect this stuff. I think even, OpenAI released, when kids were using this to generate their essays and things like that, they released a tool that allowed teachers to kind of detect whether or not that was the case. And so you're going to have models, I think, detecting models probably going forward for a lot of these things.
It sounds like the education industry is going to be heavily impacted by this as well, because now you need tools on top of tools in order to know what was actually being created by AI or not.
For sure.
Can you chat a little bit more about next generation of product that we can see?
Yeah, so I do think probably in the short term, probably the biggest benefits you're going to see around, again, very human language application. So how can I summarize and synthesize information? So people are like, what is the evolution of search around kind of GPT? And rather than you having to go and scroll through a bunch of different websites to kind of you aggregate the information yourself, it can be really good at taking kind of information, ranking it, and synthesizing it all together in a summary for you. So give me a 100-page document and give me a summary of it. That's actually probably what it's going to be really good at in the short term. The long term, I think, is more interesting. We can talk about it a bit when we talk about how it's going to impact, I think, the accounting and finance space, I think, as well. But as like an instruction set where you can kind of ask a human question and then have it go call other functions or other things to do kind of some symbolic manipulation or math somewhere else. So, we talked about hallucinations a bit, but one of the other things that these models are quite bad at right now is math. And just because they're not trained on kind of logic or symbolic manipulation or anything like that. Again, it's just kind of mimicking human speech. And so, you can ask a lot of times to do a math problem and it'll give you 3 different answers if you ask it 3 different times, because it's just not built to understand things that way. So there's a lot of areas where I don't think it's going to have a huge impact in the short term, but certainly it's going to be a piece of the puzzle for solving some of these things long term. We can talk about some of that stuff.
It's a perfect gateway for us to talk about, will AI, machine learning, or even BARD and ChatGPT impact the accounting industry, and why?
So I think the answer is certainly yes. The question is kind of in what areas and how much. There are some people, schools of thought saying that, just feed an LLM kind of gap rules and then have it go, and everything should be automated, and the accounting can be fully kind of done by a transformer. And that's almost certainly overblowing what they can do, not only because of their correctness, but just in terms of structure, right? We talked about how they're not that great at math, and in addition to kind of the hallucination, and there is a lot of math in kind of the finance and accounting world, right? So, but also, at some point, the physical world has to meet the digital world. So things like the use of equipment for depreciation or something like that needs to be recorded by a person. Like that information has to get put into a system. So, GPT won't be doing that. And that's just a simple example, but it just shows that it's not really as hand-wavy as, this is just going to kind of revolutionize an entire field and everyone's going to be out of work and blah, blah. It's really, if anything, it's just going to make supercharged productivity a little bit, like most tools. I think the analogy to self-driving cars is probably a good one here, where, when the initial demos, when we first saw this stuff like 10 years ago of a car on a highway driving itself, it seemed like, the future was going to happen tomorrow, right? This was about to change the way we drive, and it still is. Like, it's an amazing, feat to be able to do what a lot of the self-driving car, algorithms have done. But the edge cases, right? The pedestrians, balls bouncing in the road, a cop pulling someone over, a blown tire, things like that. That's the really hard stuff. The devil is always kind of in the edge cases. And that's true of, I think, problems in every field, and certainly in kind of the finance and accounting space as well. And again, I don't say that to discount like the incredible progress made by a lot of these kind of scientists and researchers that are doing this. But, we're many years past when I think people initially thought this was going to happen, because the edge cases are really hard. Hailstorms and things like that are really hard to have a car drive through when it's blocking all your sensors. So we talked a little bit about why we started kind of solving these problems that we solve, and just to get into more detail about what we do. We clean, normalize, and stitch data together from a lot of your different kind of financial sources. So connect to your order system if you're an e-commerce company, pull in kind of your OMS data, we'll pull your payment processor data in, and your bank data. And what we try and do is stitch together across all these systems. We'll create an audit trail kind of on an individual transaction level that takes you from like birth to death of an order. And so in that way, like a lot of problems, a lot of your accounting, a lot of your reporting, a lot of any like intelligence you want to know how your business operates becomes a very simple aggregation on top of that information once we can create this kind of cleaned, normalized, stitched together data set that shows you everything that happened from kind of birth to death. And a lot of that is built on top of a few different things. So it's obviously a lot of data engineering work. We have to go and get the data, we clean the data, but it's also a lot of intelligence we kind of place on top of that. So we do a lot of testing to make sure that the data actually makes sense. It's kind of how we expect it. So that's where we employ some kind of machine learning algorithms to do anomaly detection. Do things look weird? Have things changed a lot in the past? Should we alert you of things? We have quite a robust set of kind of data integrity checks to make sure that that stuff looks okay before we show anything to anyone. And it's kind of a self-fulfilling thing. So once we can audit trail something to the bank account, we know it's kind of correct, right? Because cash is kind of an ultimate source of truth in a lot of ways. And so that way upstream, when you're reporting on stuff for your company, the operational data is correct because it is tied to something that we know is correct downstream. And on top of that, a lot of times there's not a clear key to match these things across these systems. And so we write a lot of algorithms to be able to detect, how can I tell that this record over here is this record over here? Or how do I break apart this like $100,000 bank transaction into its constituent upstream pieces? And so we write algorithms to do that stuff. So, ours are very particular, like they're not quite language models. We have particular tasks that we want. Most machine learning models are quite focused in what they do. I want this task to be really good, and you give it kind of a training set and kind of this is what it should look like in the end, and you kind of optimize for that. But it is interesting to think about, I guess, how will something like GPT actually impact what we do? And every company should be thinking about this, or every machine learning team should be thinking about how this stuff can kind of augment currently what our process is. And so as we kind of have been thinking about it, internally, like I mentioned, these models are particularly bad at math. So I wouldn't say like, hey, we're going to throw all of the sums and things like that we do, and here's a data set. Can you just summarize? Give me what my journal entry should be, whatever, from period 1 to period 2. It's not quite at that point just yet. But the structure, I think, it is interesting to think about, like, well, why can't you ask it a human question and just have it go and tell you, like, this is what kind of the journal should be? Part of it is that it is bad at math, but can it answer, rather than have it answer a question itself, can it understand what question should be asked to something else? So rather than have it be the end-to-end solution, you have it basically call out, like it's connected to a code interpreter, right? That can take a data set in and then sum stuff up or interpret the data itself. So it's not doing the symbolic manipulation. It's just asking the question. It's something with a more logical framework can actually go and do kind of summarization or things like that. Or symbolic manipulator like Mathematica, where you can actually do, proper math underneath the hood. So the transformer like becomes an instruction set, kind of knowing what questions to ask, but not needing to be good at logic itself. And I do think that'll be a pretty interesting way for humans to kind of interact with this stuff in the future. And again, you still have the problems of like, well, anyone who's dealt with kind of cleaning data sets or dealing with data sets before know, like, the devil's in the interpretation of like, well, what does this column mean? Should it actually be a number? Like these things are not really what transformers are good at just yet. So I do think there's going to need to be, we're not quite there for these to be useful at the moment, but I do think it's like probably on the horizon where you can ask a question of your data and you'll get a good answer if it's connected to a good logical system at the other end. I would probably evaluate in the same way that you think about, well, where should software kind of be applied? You start by identifying kind of manual repetitive steps in kind of any workflow. Those are always kind of the lowest hanging fruit. So what counts as like, your manual processing? Are you downloading a ton of like spreadsheets from somewhere, trying to stitch stuff together in kind of Excel? If your Excel workbooks are starting to break down, that's probably a good sign that it shouldn't be in an Excel workbook anymore. It should be in a database somewhere. It's a clear sign that like someone should be building something somewhere to kind of automate that flow or clean something up there. And I don't think that changes with kind of the GPT flow. I think it just changes kind of the interface and how much you need to, of the software you need to kind of build yourself versus kind of allow it to kind of do it for you. And that's where you kind of see, especially in kind of the code links, you can build a lot of the code for you, which is amazing. But you don't, Yeah, I think it starts from kind of the same question of kind of what is my low-hanging fruit that I can kind of automate my repetitive tasks away. Data entry in a lot of ways. So taking invoices and kind of structuring them is probably a field that I would see working to, like taking OCR, optical character recognition tasks, and having GPT kind of automate a lot of that stuff away, or any other transformer, I should say, things like that. Give you kind of a workflow of what our customers tend to do. So, if let's say we're connected to a large e-commerce company, they sell on multiple different public platforms. They might have their own service via Shopify. They sell on Amazon Seller, maybe through some wholesale channels. That's kind of their order information. Then they process their kind of payment information via whatever Stripe. They have PayPal. They have a buy now, pay later, like Afterpay or Klarna. They may have a few different credit cards if they sell in different countries. And then, they have this stuff settling into a few different bank accounts. And so what we'll do is we'll kind of connect to all of those different systems, and automate the kind of pulling and kind of cleaning, normalizing, and stitching that together. So you get all of that information in one place. So in orders and orders and order, regardless of where you sell, same with payments and same with kind of bank data. We'll stitch all that stuff together and kind of provide automated journal entries for, what did I sell this month? What revenue can I actually recognize? So we'll take into account fulfillment information to let you know, like, here's actually of what you sold, here's what can be recognized in this period versus that period, what's kind of still outstanding, what's my cash in transit, what's my deferred revenue, things like that. So, just by structuring a lot of this data and cleaning it, it makes a lot of the calculations quite simple, I would say, by getting everything built on top of a clean data set becomes a lot easier. Exactly. Our goal is to make everything as transparent and auditable as possible. And again, we're big believers that everything built, if the data set is good and clean and we have confidence in it, then everything else becomes a lot simpler. And so every number that you kind of see is auditable. You can click in on anything and tell exactly what transactions made up these kind of summary numbers, from what I was talking about earlier, from the journal entries to like deferred revenue numbers down to the line item level. You can kind of see all the products and things like that that make up all of the summaries that we've created. Yeah, I mean, look, I think we're very much in the early stages of this. I think there's a ton of exciting stuff. And sometimes you see some of the doom scenarios and you're like, people, it's just the same thing over and over again. I've seen this cycle like, 3 times at this point, just in the last 10 years. But I do think that, there's clear evolutionary progress here. And this is, transformers have been kind of a step function change in kind of the abilities, at least on the language side, of what can be done. And so what I'm really excited about is, again, using kind of these transformers as kind of the instruction set. They're not necessarily doing all the calculations, but they're connected to things that are, again, logical manipulations. I would love to see it connected to, again, now I think code interpreters are starting to be connected to these LLMs. So it gives a instruction set of here's what to do, here's what to sum, here are the calculations to do, and then like kind of return it back. And it just has to be the interpreter of information as opposed to actually the calculator of it. And I think that's where the most interesting stuff is going to change. It's going to change the interface between humans and data and math and things like that.
We're at the end of our webinar. Thank you all for joining, and thank you, Manav, for giving us a quick talk about